Welcome to this session of Data Summit Connect, Embracing the Data Analytics Revolution. And our speaker is Ryan Gross. He is the Vice President for Emerging Technologies at Pariveda Solutions. And Ryan leads the go-to-market endeavors at that approach at Pariveda. He's written a lot of articles on DataOps, and he tells me that some of this presentation is based on some of those articles. And so let me also thank our diamond sponsor, Sumo Logic, and turn this over to Ryan. So Ryan, if you want to unmute and share your screen. And while
Thank
he's
you.
doing that, remember that if you have questions during his presentation, put them into the Q&A box or chat. Go ahead.
All right. Thank you, everybody, for joining today. Hopefully, we'll make this somewhat entertaining exploration through the origins of DataOps and really some views that I've got around how they're going to affect the practices we use for data governance. I know data governance is one of those terms and one of those concepts that is always brought up, is always on people's minds in terms of something that must be accomplished. In fact, I think 90% of executives recognize that data governance is important in most surveys, but in those same surveys, the same executives say that only maybe 20 to 25% of organizations feel that they are competent at data governance. And even within those organizations, data governance is seen as a hindrance to the capture of value to their analytics efforts rather than something that's helping them out. And I really think that a lot of the reason for that is that we've always been driving from this place of fear, and fear-driven governance does not work. We've been working towards these processes whereby we have regulations from government bodies telling organizations what they must do with data. And then organizations react to that. They bring in governance councils and committees. They build review meetings to make sure that things are actually complying with the rules and regulations that are being applied to them, all the while pushing back against the regulations. And in reality, I think the actual people who are on the ground trying to get the governance organization to work don't have the right motivators. That fear motivator simply doesn't work in this case over a long enough period of time. So what we find with that is that governance is often the weakest pillar in a modern data enterprise. We at Pariveda focus on a three-pillared approach to realizing data analytics initiatives within an organization. First one focusing on the business value you're delivering, second on the platform you deliver it with, and the third one on the processes you use to operate that platform, the governance processes. And what we find is that most organizations, as they go through this fear-driven governance approach, end up applying legacy manual governance processes to move from an ungoverned state into this state where they're reacting to changes. Maybe they've defined data stewards. Maybe you've gone through and assigned data custodians to clean up and increase the data quality that you're serving up. But those people in those roles are either part-time and being asked to do this on their own via extra effort, or they're not necessarily quite sure what value is being gained through their efforts. And so they're just taking this blanket approach. Let's make sure that we have data definitions for every single field, that every single field retroactively is tracked for compliance reasons. And over time, that motivation wanes. The headlines that started it, where some other company in your industry was hit with a large fine due to a GDPR violation, or the data breach that was all over the news fades as the next news cycle takes over. And slowly the organization fades back into being in an uncontrolled state till the next news cycle brings attention back, and this loop starts up again. And what we find is that it's very difficult for organizations to move beyond that into something where they're more proactive, and governance is actually taking hold as part of everyday activities. Now, our whole goal in building out a modern data enterprise and in applying governance practices is really to deliver on some guideposts which haven't changed. So you still, in today's modern world, have to focus on ensuring that data is of high quality, that people can find it and get access to it when they need it, that you're complying with the laws, that the data platforms, pipelines, and data sets that you're building up are regularly available and refreshed, and that all of this is done in a secure way to avoid the data breaches that I was mentioning before. Now, to dig in a little bit on what it looks like to do data governance, in most organizations, you have, at this point, the appointed position of a chief data officer who owns the overall strategy around governing, managing, and potentially valuing the data assets in your organization. If you watched the keynote earlier today, you got a lot of insights into different ways that you can do that and to increase the value. And that chief data officer works with a set of data stewards who are aligned to the people in the business that are actually delivering on the value, to make sure that they understand which data is most important. And then underneath of them sit a set of data stewards and data custodians who are out there working on improving the data's capability to meet the guideposts that I just shared, improving the data quality, ensuring data is available and potentially cataloged. And when you fast forward, as people have gone through this cycle 4 or 5 times of spinning this up, what this looks like in many places in 2020 is pretty much the same. There's just more data stewards and more business unit leads being involved in the process. The whole thing has become very heavy and cumbersome, and the headcount has gone up. The amount of time that these people spend in meetings has gone up dramatically, because ultimately, once you start to hit a certain point of scale, manual processes add overhead that is just communication and management layers that aren't really adding value. So in reality, when you look at one of the key measures, and we could say this around most of the others as well, it stayed somewhat flat over time. Now, looking at this, it's pretty clear, and I think that almost everyone agrees that this is a problem. This is something that we need to address in order for most organizations and to be able to start to leverage data at scale. Even those that are out there as leaders right now, the social media companies and tech giants, actually still struggle with this, and you're starting to see it. The overall techlash term that you're hearing around people being fed up with the way that their data is not necessarily being governed and managed for consistent use. It's starting to come back to bite those companies. So given that we have what seems to be a systemic problem, it really means that we need to start to think about a more systemic change in order to fix it. So we don't need to just worry about the events or the patterns and trends that I'm talking about here, but ultimately we have to go all the way to the bottom of the iceberg and look at the mental models that drive people into these ways of thinking around manual governance application, councils and committees, stewards who are outside the process of actually delivering the analytics that drive value. In other words, maybe we need to reframe the whole problem. So I was introduced to a book by Keys Dorst within our company here. Reframing of problems has led to some really interesting solutions. He was looking at this in societal problems, like how do you manage crime in urban areas where many people are going out, or how do you manage public works of art that are often being used for protests. And it's by reframing the way that you look at those problems that you can come up with innovative new solutions to them. In his example, one of the most interesting ones is looking at the Sydney Opera House, where people are protesting and using that public work of art as a venue for their statements that they want people to see. So instead of banning anyone from getting near the building, what they decided to do was take the example of a public work of art and make it so that you couldn't actually do that because people are always there. They encouraged more people to come in, which took away people's ability to set up these types of protest displays alongside what was supposed to be there. So thinking about it in a new way gave them a new way to solve the problem. For me, when I was thinking about this data governance problem, and this is probably 3 or 4 years ago, I attended a conference in Philadelphia where I saw a presentation by the head of the AI practice at Amazon, at AWS, at Amazon Web Services. And one of the key points he made is that with machine learning, data is actually there to write the code. That means that machine learning and our data pipelines that feed it are actually now writing the functions that drive a lot of what we see in the world today. And that was really that aha moment for me, that the new frame to look at for data governance is actually software engineering. Because software engineering obviously is the process by which people write code to build something out. And if within our data and analytics space, we're working with data writing the code, we can rethink the way that we look at data in order to help solve this problem. So let's take a trip back in time briefly here to start to look at what it looked like to be a software engineer, or really a computer programmer, an artisan in the 1960s, working on manual processes to build entire programs end to end. It really required heroic efforts and was very, very difficult to achieve in any way that it actually would move the needle meaningfully within most organizations. So you end up with a scenario where you need some key innovations in order to move things forward to a team sport that people can start to build upon, to transition from this artisan coder to a software engineer. And I really feel like there's two core innovations that created that discipline. The first one is the ability to compile your input code into executable outputs. That means that you have a whole set of inputs in your source code that can be much easier for people to understand. And then through this complex process, you translate that into something that is executable on the machine. Now, that makes it much easier for the average person to come in and be able to build the source code here, and pushes a lot of the complexity into the compiler layer, getting to these intermediate optimized forms and then pushing those out onto specific hardware for execution. And that's really good. Now you still kind of need one programmer to build most of the code in that world. So the second component here was version control systems that allowed the transition from individual contributors to team contribution. So those version control systems allowed multiple versions of the code to be maintained over time, and for there to be specific points where you have two people coming together to create one program. In addition, it allowed all of the people who are working on this program to see how it evolved over time. Those two things together provided a base layer that then enabled people to start to move into higher and higher constructs, building on those fundamental constructs in order to build up to something like what we're seeing today with modern software development. So the creation of higher level languages like Scala, Python, Java, in order to make it even easier for people to write the code. Automation of testing was one of the next key innovations there, because the fact that you can start to verify that that code is correct without having to have manual intervention. It used to be before something was put into the computer, you actually had a team of people pouring through the source code looking for problems. Now you simply just look at the test reports and you say, this is good. On top of that, you also have things like static analysis, where you can have assurance that not only is the program correct, but also that it's following best practices as you've defined them within your organization. And then those have continued to build with continuous integration across those teams so that you always know that your code is right at any given point in time, and the ability to refactor and improve on that code quickly. So that's the compiler and version control, leading to higher level constructs, which then bring you into the ability to change the way that you develop software overall. So you can have an entirely different process by which you actually build this out. You have the adoption of agile techniques on top of this to enable those teams to work in defined increments, always keeping things ready to ship. And that cultural shift is actually what really led to the exponential improvements that led to, that 2000s mindset, or late 90s, early 2000s mindset that software is eating the world. And that's all well and good in the world of software. And sure, we have great practices now that are very well understood, very widely diffused throughout the world. But how can we take those and apply them to a different domain? I really think we've already figured that part of this out as well. Because if you take a look at DevOps, what we've done is found new ways to bring compilers and source control to the world of infrastructure. So it took a lot of innovation to build this compiler layer here. And that was companies like VMware coming up with virtualized infrastructure, and then companies like Amazon and Microsoft and HashiCorp coming up with things like CloudFormation, Azure Resource Manager, and Terraform to provide infrastructure as code. That includes your networking, your compute, and ultimately these days, pretty much every single component of an application can be provided as code. That code can then be versioned in modern version control systems, and the compiler actually takes these templates, scripts, and policies and makes them executable, actually stands up real infrastructure configured in a real data center somewhere that is likely off-site from where the coders actually sit. So this is almost like a much more advanced compiler that enables us to take another domain and apply the same principles. Now, I wasn't there in the probably 70s when the first version control systems came out and software teams were trying to figure out how to adopt them. And I'd imagine that they had some pushback on, wow, this new way is never going to work. It's not going to be able to be applied successfully. I was there though, as that happened within the rollout of DevOps. This same exact process repeated itself. We had virtual hardware, templatized code to define that infrastructure. Operations teams everywhere said, this isn't something that is going to really affect us. And over the next maybe 10 years, we've moved to a world where continuous deployment is almost the norm in new projects these days. We've developed serverless technologies whereby the underlying compute is actually managed by the cloud providers, and all that's necessary in order to deploy onto it is writing the code that fits a specific specification. And that's completely changed the culture of the way applications are developed. These days, the operational constructs around monitoring, around deployments, around incident response are encoded within the solution. And on top of that, things like ensuring the application is secure, meeting security scanning practices, somewhat akin to the static analysis we had on the software engineering side, are being applied on a regular basis on about 25 to 30% of projects right now. But that process is starting to increase. This diffusion is happening to the point where if you project out 5 or 10 years from now, this will be the way that software is developed everywhere. So if you think about the process we've gone through here, we developed a few core innovations, the idea of compilation, the idea of version control. We then built a whole bunch of changes on top of them in terms of improved technology layered on, then process and organizational changes that led to culture shifts that led to an exponential impact. And that brings us back to the world of data. So I'm imagining you're seeing where I'm headed with this, but looking at the fact that within the world of data, machine learning makes it so that the data writes the code. So if the source code is the source data and the resulting delivered analytics model is what it is compiled into, that means that the data pipelines we build as analysts, as data engineers, and as data scientists are actually the compiler that is taking the source and converting it into the executable function. Taking a moment for that to set in, that means that really every organization out there is like it was back in the 1970s. Everybody's writing their own compilers to take their own proprietary source code and convert it into their own proprietary machine learning models that are ultimately the functions that are writing a lot of source code these days, a lot of the most interesting things that are being done at least. But we don't really have version control on our source data right now. And that's something that I think is one of the key things that needs to change. But then second, we need to think about the way that we build these data pipelines differently. Because if they're really like a compiler, there needs to be a lot more rigor among each of these steps as you move to intermediate transformations, such that we can start to apply the activities that we normally do retroactively. In the world of software engineering, it was those code review boards. In the world of operations, it was the deployment review boards. I don't know if anybody worked in a company. I had several clients where for anything to get into production, it had to go through these 2-hour-long meetings where everybody made sure all the I's were dotted and T's were crossed before the manual deployment process was executed at 3 a.m. in the morning on a Saturday. And get us to the point where it's like things are today in the world of DevOps enabled software engineering practices, where you might deploy 25 times in a day, but you feel confident that everything you're doing works along the way. So why isn't every team thinking about it this way? Well, I do think that there's really two things that are holding us back. First one is that we really don't understand how the data writes the code. So love this XKCD comic, which I think makes the point better than any other way I've seen this written up. That essentially the way that most people treat data science and those last steps of compiling your data into the code as this pile of linear algebra, and you go through experimentation. Your data scientists experiment to figure out what the logic will end up being. And they just continue changing that until the answers actually start to match what you would expect. And then later, after the data scientists have worked, the ball is handed to a set of data engineers who come in to build that optimizer, that pipeline that actually ensures that this process is repeatable and that there's a level of rigor applied along the way. And the second one is that we haven't started to build on top of the capabilities we have around versioning data and compiling into intermediate forms. So we don't have that concept of multiple environments with which to test. We don't have that concept of ensuring that governance concerns like access management and privacy are baked into each stage of our data pipeline definition, similar to what we have with ensuring that security best practices are baked into the way that we deploy our infrastructure and that we then deploy our applications onto that infrastructure. So our next step here is really what gives rise to the concept of DataOps. And that's applying these software best practices to manage what we don't fully understand here. And that's where DataOps, the term, has been born. It's really taking these agile DevOps principles and applying them to the world of data. I'll leave off lean manufacturing and come back to it in just a moment, because the agile and DevOps practices need to take into account that the data itself changes. So our development environments that we move our data pipelines through, taking it from an idea into development, verifying that it is correct, needs to take into account that the data is ever changing as well. So the data that flows through the production pipeline tomorrow will not be the same as the test data that you have in order to build this out today. So taking care of all of those different data scenarios is really important, especially once you start to layer in additional concerns like access management, privacy management, data availability and discoverability onto this. And that brings us back to the lean manufacturing approach, which is to leverage the testing that's built during development in production, so that you're not only testing the code and the logic, but you're testing the data itself. You're testing that things meet the expectations that the system has so that you can continue to deliver value. So taking that approach and taking it to the next step, how do we start to take the lessons that we have learned from agile development, from DevOps, and apply them to the world of data? First thing you need to do is continue to expand the sphere of things that are defined as code. That means everything about your data platform and pipelines should be redeployable into any environment at any point in time from source code that is versioned in version control. That starts out with the pipeline code itself, the actual logic that does the data transformations and is the compiler in this case. But in order to work with the fact that we don't understand 100% of how everything works to compile data into code using machine learning. We also need logic tests along the way to ensure that the data meets the standards that we have. We need to ensure that the environment that this runs on top of in our development environment that then moves up to the production environment is codified, so we know that things aren't really changing between those. In fact, the pipeline that actually does the deployments into each of those environments should be codified. Now, in addition to testing that the logic in each step is correct, we also need to test that the data that is flowing through is correct. So that means test data management, as well as ensuring that the data that flows into intermediate steps meets a certain set of preconditions that your logic tests expect. And if you have anything that doesn't meet those, you can send it into a quarantine area, or you can flag it if it's not necessarily something that's absolutely critical. And then finally, in today's world, access and privacy to the outputs of each stage in a data pipeline need to be managed as well. Now, the final step here, a lot of what we talked about there was within each stage. The final step here is that the set of dependencies. So within a data pipeline, each stage depends on several inputs that are also produced by data pipeline stages in many cases. In some cases are ingested from the raw data sources themselves. So there's the level of dependency and the orchestration of these pipelines that also becomes part of your deployment package. So in order to meet the challenges of moving through data pipeline deployment processes that we've brought forward from DevOps, and to do this in an agile way such that you can continually add new changes to these in a safe way and have that continuous delivery type of approach, we need this everything as code approach. And so what does that buy us? So projecting forward, what would it really look like to realize this vision? Well, let's say you want to be able to onboard new data sources in one day. New one comes in, it's similar enough to something you've already seen before, you know which tests to write. You can move it from POC into production that day and allow people to start using it. You can do this without writing incremental code unless there's actually something new that needs to be done with that new data type. You could remove all the inefficiencies that come from pushing something into production, waiting for a batch job to complete, seeing what it looks like downstream, then being able to think about what happens next. You could integrate it so that when that new data source is onboarded in a day, it's immediately discoverable to your organization, such that they can come in and self-serve and self-discover data sets. And ultimately, your organization can rapidly realize the deep business insights that come from being able to combine this data. Now, this is all visionary and forward-looking. And with DataOps as data governance, it's something that is imminently possible in today's world. And what most people think of as data governance processes that hold this back are actually baked into the way that you do this, so that while you do this, all the while, you still are providing compliance and security around the data. So if that vision sounds good to you, the next step is really to start to think about how do you realize that vision. I'm going to talk about the underlying technology components that are setting up the ability to do this. So looking back, our guideposts around data governance, quality, discovery, compliance, availability, and security have modern tools that enable you to move more quickly. So in the quality area, you have data wrangling tools that allow you to get that visual view of data quality, build quality rules, and understand the current state of data more quickly. Those are good for understanding the data quickly. The next step is that codifying the output. So there's pipeline testing frameworks like SOTA data, Great Expectations, and Toro data that enable your organization to very quickly have code-based data tests alongside the code that transforms that data. So you may learn from Trifecta, Paxata, and I know Paxata is now part of DataRobot, but what your current shape of the data looks like, and then encode it in Great Expectations in order to say, here's what my data must look like. In order to tie that in such that that data is immediately discoverable, there's a whole category of ML-based data catalogs that learn about the data not only from manual intervention to define documentation, but also understanding how people are using that data or the profile of the data. So Alation has really good capabilities around query log mining to understand exactly how people are using your data, such that you can continue to find things that may need to go back into your pipeline testing. Then systems like Waterline data provide you with the capability to take those black box data sources that you haven't seen before and understand them in a deep way. It has really unique column fingerprinting capabilities that enable you to understand how your data might join together and what particular issues might exist, while making that available and discoverable to a analyst user base. Next step is rapid exploration. So even before you bring something into a data platform, there's now tools that enable you to get in there and really take it to the next step beyond what you can get with the visual data wrangling tools that enable that discovery to go to the extra depth where you understand the logic and you can get through that experimentation phase to understand what changes are necessary in order to get from your source code to your compiled output. You also have the ability to bake in compliance. And this is an area where I think things are maturing. So I separated out the ML discoverability focused data catalogs from the ML compliance focused data catalogs. I think that this is really starting to blend as we speak, such that in the next year or two, you'll be able to get both the compliance side and the discoverability side within a data catalog product. And part of that is because some of these players are starting to blend in these data privacy tools that surface data privacy concerns along the way, and again, enable you to codify the management expectations around this, such that as people are developing data pipelines, it's not something that they have to come back in at the end and seek approval that they met privacy needs. It's something where it can be verified via test automation that was happening, and that you can scan and find areas where it has not happened and correct those. Moving forward, availability is all around ensuring that this runs on an ongoing basis and that you have the ability to see what the data looked like at any point in time. And that's really where tools like DataBand, StreamSets for data pipeline building, and then Prometheus for being able to build the observation into your data pipelines to see what's actually happening as they're running in production, taking that step that I was talking about before of lean manufacturing principles, applying your tests to the data as opposed to just in the development process. And then at any point in time is now readily available to anybody, primarily in the world of Spark Hive big data platforms via the Apache Hudi project coming out of Uber or the Delta Lake project from Databricks. On the far right, access management is now manageable as code using tools like Privacera, which is built upon the foundations of Apache Ranger in order to provide codified data access rules, and one of their key competitors, Immuta, who has taken that even a step further, such that you can look at attributes of your users and attributes of your data and use that to combine to build the access management decisions at query time. And then in more widespread use, things like AWS Lake Formation and the new functionality that's being built into Azure Synapse Analytics are baking that into the platforms that everybody uses on a regular basis. And then I think encryption is one of those things where it's now by default across any platform using things like key management service, things like the Key Vault in Azure or HashiCorp's version if you're on a third-party platform, such that you can manage your own keys and ensure that only your organization has access to decrypt the data, preventing challenges if that data happens to leak out. So next thing I want to talk through is how do you build out a data pipeline using this new approach? In this case, let's just say you're building a financial data pipeline that's going to build a dashboard around combining some internal banking data with external data that's coming in from companies like Bloomberg or Dow Jones. So your first step is you have your existing data lake, and you can bring that into your development environment. You can easily these days, either through managing access, where you can provide cross-account access via AWS Lake Formation, or through data cloning using tools like Vertica, who I know is presenting sometime during this conference, or Snowflake, enabling that type of multiple versions of the same data without actually replicating all of it, such that you're developing in an equivalent environment. Next step is to design what you want to build. We talk a lot about this right to left, right? What do I want to build? And use that to figure out what I want to ingest. You can then build up those test data sets around your input data from the bank, input data from your external vendors. And you start to build those tests in Great Expectations to verify that everything that's coming through works as you expect. You might inspect the data using something like Trifactor Wrangler, or pull it into a catalog, pull it in and catalog it in something like Waterline to understand what's underneath, then start building those tests. Next step is really to build a prototype. You don't necessarily need every pipeline stage at the beginning, because you're focused on, am I getting the right end state value, right? Is this dashboard actually meeting end user needs, before you go back and add all those additional layers of tests along the way. As you're building out the next step here, you start to break into different stages of your data pipelines and different testing concerns around each stage. You might have static analysis is the wrong word, but you might have rules that actually ensure that specific types of tests exist, for instance, around your core data model data, that your data access policies are proper and not too permissive, and that after you've built your pipeline, there's end-to-end tests that show that each of the stages along the way give you what you need. Then, because you've defined everything as code, you can promote it into production, hook it up to the real data, and leverage those same tests along the arrows here in order to find the data that doesn't meet expectations, the same way that you found the code that didn't meet expectations down below. Once everything looks right from a data perspective, you can then really launch that dashboard that's going to drive value into the real world. From there, you're able to start to layer in additional changes to the pipeline very quickly. So let's say you add in one more data source, you just add that data source, you add maybe 3 or 4 more tests along the way, and you can re-execute that deployment and get those changes out the door in a matter of a day, where in the past you might have had to comply with some release schedule and it might have been 2 weeks or a month before something simple could get out into production. That level of agility is really what we're looking for with using a DataOps approach, while still maintaining that access policies are managed, that end-to-end functionality is correct, and that data products built along the way, these intermediate data products, are also reusable. So next thing we want to do is look into what do the tests themselves look like. So here's one example. I'm not going to go into a full run through of this, but this is one type of test that comes earlier in the process here, oftentimes around your data modeling itself, to ensure that everybody can trust a set of conditions when they're using these reusable data assets. So first off, it comes out of the idea for a data product planning process. You understand what the inputs are. The dev environment that we just talked about is spun up. And the person who's actually building that end state dashboard starts to encode all of the different rules for what data inputs must meet. So something around anomaly detection, anomaly ranges of increases or decreases in values, things like key patterns around string fields, or the relationships among tables or among different data objects that are being joined. And then you build the data pipeline that actually executes on the creation of something that meets all those rules. You can then generate test data that actually meets all of the potential input data definitions, such that some of those may fail because either the data generated isn't realistic or the code isn't properly handling edge case scenarios. You then layer in better tests, improve the code, or tighten up the definition such that by the time you complete the loop, everyone knows exactly what to expect along the way. Now, this process takes a little while to get started in an organization, and it's something that is probably a sign of a more mature organization that you would be executing on something this robust in the majority of cases. But it's something for those key data assets, right? Your key definition of customers or products or something that's reused frequently, to start to use this level of testing rigor. For the rest of the world, in order to get started with something like this, I'd suggest a little bit more of an incremental approach. So first thing is, start out by focusing on value. Identify and assess and prioritize the use cases that you're going to use to roll out this new way of working. Then your data management team focuses on enabling those use cases. They focus on the ingestion side of things. What are the data sources? What data quality problems exist in them right now? How can you combine them together? People who really know the data working, with the analysts who are trying to derive value from it, focused on enabling. Then, as you build out the experiments and get that prototype developed, you have the time to build up the capabilities such that you can apply the governance that says, yes, you did control for those data quality issues that were the most important for this particular use case, and you did ensure that access is managed along the way to each one of those data products, intermediate and end state, such that the governance approach here is not a manual counsel review. It's of the code itself and all of the details. It's really looking at the outputs of the reports that were run in your development environment to understand that, yes, this is correct. At which point you deploy it out and start to capture the metrics around the tests running against the data, ensure that those constraints are enforced, spin up that data curator role as it applies to data that ends up in quarantine situations where there's clear motivation that the value you're deriving from this use case. Let's just say that we were building a trading algorithm in that prior example. The value of that trading algorithm justifies the need to clean up any data that flows through and ends up in quarantine. And over time, you report back on the value of what's really being achieved and the fact that you have been building in avoidance of some of your downstream risks. So as you look at that infonomics type approach, you can start to report on the fact that, yes, you are being continuously compliant through all of these processes, avoiding risks of the multi-million-dollar payouts that come with GDPR violations. Ultimately, this will start to build up into something that looks a little more like this. This one I'm definitely not going to go into detail on, but you can actually start to encode the whole process end to end such that it can be rolled out to more teams. It can be scaled up within your organization. And finally, as you mature, you move beyond just thinking about this as a data ops problem, right? Those technology and process components that enable you to build in governance type concerns to the actions that you're taking. And you look at it as more of a modern data management approach. So taking things like managing the trust in your data as opposed to just minimizing data issues is how you move from that just getting started through to the scale out, and then get into that point where you are starting to take a look at the long-term organizational culture changes that ultimately are going to drive that exponential improvement. So going all the way back, just like we looked at with software, you start out with the technology, we build some concepts on top of it, we change the processes and the way we do things using data ops. And as we mature, the culture shifts where we recognize those exponential impacts. So with that, I really appreciate everybody's time here, and I will turn it over for questions.
Great. Thank you, Ryan. Actually, I love the way you've tied some of what you were saying in with what Doug was talking about in our opening keynote. I love it when things fit together like that. It's just gorgeous. I was also struck by, in one of your very early slides, the number of hours in meetings that had gone up dramatically. I'm not sure what date that was, those data were collected, but I would be willing to bet that it's even higher now, just because nobody goes into offices anymore.
Mm-hmm. And yeah, in today's virtual world, things that were once done ad hoc are now meetings.
Exactly.
And so that's true.
Yeah.
It probably even increased that.
I think that if you do this again in a month or so, that graph is going to look different, and it's going to be worse.
Well, hopefully, as these data ops concepts catch on, it'll start to flatten that curve as well.
I'm also struck by your final points on trust, because I think, again, in the world we're in right now, where data is becoming almost differently defined in some ways, that more data is around, more people are concerned about it. And I think some of what happens in the public world is transferring into corporations, into companies, into internal data, and this whole issue of what do we trust and what don't we trust. I think that's going to become more critical. I don't know if you agree with that.
Yeah, I do. I very much agree with that. I think trust is, obviously it's a word that needs to be defined in this sense, where there's the trust that the data is correct. And that's a lot of what I think internally within organizations, people are focusing on managing. But these days, there's also that layer of trusting that the data is being used for its intended purpose. So that external, like for data that is about people, there's that second layer of trust. And I don't know that I have an answer for how you can encode that into your processes. I know that there's definitely people working on that right now, and there's a lot of really smart people working on it. And I think there's going to be, that regulatory pressure to get it right. Yeah. So it's something that is going to be a key topic of conversation, but also of innovation over the next couple of years.
Absolutely, absolutely. We have a question here on a Greenfields Fresh Data Ops project. What should the main focus of your DevOps team be to start with?
Yeah, I think I talked a little bit around the way we see rollouts work best is not to try to take these data ops principles and apply them to everything all at once and have this big data ops project where you completely change everything. It's to take a few use cases, make those ones where there's both high value to be achieved, but also a high need for the rigor that you're talking about. So something where you are processing personal data or where you are combining data sets that weren't normally combined in the past.
Yeah.
And then your DevOps team focuses in on three things. One is environment management. So making sure that that data pipeline environment can be exactly reproduction of production across both the infrastructure layer and the data layer. Second one is that testing framework, including that both test data management and the ability to actually specify that data at this stage in the pipeline should meet all these conditions. We're really liking Great Expectations, and there's a lot of community support around that these days that's making that easier and easier with different types of add-ons for it. And then the last piece is the DevOps team focusing in on that access management as code layer. That usually is something that's new from a data perspective. Oftentimes you have the infrastructure access management as code, but that data access management, looking at tools like Immuta or Privacera as one way to get that, or trying to build something on top of something like AWS Lake Formation. That's probably where the DevOps team focuses, and then analysts and others focus elsewhere.
Okay, I'm not sure whether this is really a question, but let's try it. This is in chat. How about this design flexible for introduction of synthetic data in non-production environments from simulations, data sets with predictions and algorithms? This seems like lots as opposed to an actual question, but if you have comments, go ahead.
And so if Mannion, if you wanted to type in if I'm getting it all wrong from a question perspective, it's this sounds like that test data management component here. In IoT scenarios or other things like that, you may need to simulate the real machine or the real world scenario in order to generate some of that test data. Okay. I did talk a little bit about taking the specification of what you expect that data input to be and encoding that almost as part of your, air quotes here, schema definition for that data. And then you can use, rather than needing a full-on simulator, you can start to use a generator that focuses on generating anything that might be possible given what you've specified as constraints. And that'll ensure that you're catching all types of edge conditions. I know I worked, one of the first large projects I worked was an IoT data platform. And that was one of the big concerns was, we pretty much had to flow in real data from machines in the field in order to do most of our testing, because the simulators just didn't catch, let's call it 70% of the scenarios that we needed to test for. So that's really where that other approach of, hey, let's not assume that we have to build simulators that are perfect for every scenario. Let's just say anything's inbounds unless we say it's out of bounds.
Have you ever encountered a situation where you did not meet expectations, but it turned out that the expectations actually were incorrect?
Oh, yes, that's definitely true. And that is where I guess I may not have made the point strongly enough as I talked through it today. The steps of manual review don't go away completely in this DataOps world. They just get focused in on scenarios that are flagged or raised up by the automation that's built. And so that's where you end up having to go back through those observability tools become very important there. So you can understand exactly what happened that led up to data either being quarantined or tests failing in a dev environment. And I think it's probably, it's like a Pareto rule, like 80-20, 80% of the time it's usually, the data was bad or the code was bad. 20% of the time you were testing for an invalid scenario, or maybe even the test itself was improperly written.
Sure. Very good. We will be putting this video up on YouTube, but Ryan, are you going to make your slides available somewhere?
Yeah, I'll put the slides up on SlideShare, and okay. I can work with you, Mary D, to get the link to the SlideShare put on YouTube.
Okay, perfect. Okay, well, thank you so much, Ryan. This was great. I learned a lot, and I'm sure everybody else did as well. So thank you so much, and thanks also to our Diamond sponsor, Sumo Logic. And we have one more session in the conference today, so I hope you all stick around for that one. Thank you very much.
I'm looking forward to it. Thank you very much.
Excellent, great.